Our last topic, which kind of brings everything all together, is the equation of a line. And so we're going to do a couple examples. This is a bit more work, so I'm going to talk a little quicker. Obviously, you can pause at any time you want to kind of go through it at your own pace. So the first thing you'll notice here is we've got an equation. And I haven't talked much about this, but you can actually tell by looking at equation that it's linear or not. It has to do with what's called the degree of the equation, and the degree of the equation is the powers on the variables. More importantly, though, it's the powers of all the variables in any one term. So again, this is 3x to the first, and there's a separate term of 4y to the first. So we call these first degree equations, and therefore this is going to be a line, which is a good thing to know in advance, because if our points are not in a line, we need to correct them. So we learned in grade 8 and 9 something called table values, where we have a choice to pick numbers that would work. But I'm going to get you to focus on the second part. It's really useful to find the x and y intercepts for a variety of reasons, many of which will lead into solving different types of equations next year. But to find these to plot these points, what we have to do is to think about, if we're going to find the x-intercept, then we need to be aware that every point on this x-axis has a height of 0. So by plugging in y equals 0, subbing it into our equation, we end up with 3x plus 4 times 0 equals 12. Divide both sides by 3, and we get x equals 4. And that's our first point. That's the x-intercept. Again, we'll do the same thing, but to find the y-intercept, every point on that line has to be left and right to the 0. So every point in that line will have an x-coordinate of 0. So when you're doing your tables of values, plugging in 0 for x and 0 for y, in other words, finding the intercepts, is a great way to start. Sometimes you'll get fractions. Don't get discouraged. Keep going through it. If you plug in 0 here to the equation for x, you get 3 times 0 plus 4 times y equals 12. Dividing by 4 gives us 3 as a solution. That's a 0, 3 is a point. Of course, we're going to need more points if we want to come up with a line. 2 points do generate a line, but we want to make sure we didn't make any mistakes. But instead of creating more points, we are going to take advantage of the probably most important pattern or formula that we noticed in this unit, which is slope-intercept form. So what we're going to do, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And basically what slope-intercept means is you've got to get this. You've got to get y by itself. In other words, you have to solve for y. And we practiced this skill a fair amount in the last couple of weeks. Let's try it here. Solve for y. 3x plus 4y equals 12. So you know the steps by now of solving an equation. They involve doing the inverse to eliminate something, and you do it to both sides. So if we want to get rid of the 3x, we have to do the inverse, which is minus 3x. We do it to both sides of the equation. The equal sign splits it into two sides. We get 4y equals. Now we could put the minus 3x at the end, but as we know, we want to have mx plus b. So we're going to put the minus 3x or negative 3x first. Then we'll put the positive 12. Again, we have to solve for y. And in this case, we have to do the inverse of multiplying by 4, which is dividing by 4. And we talked quite a bit about making sure you do it to all terms of both sides of the equation. So our final answer is y equals negative 3/4 x plus 3. course, we could right away take a look and check that. If you go look at our graph, you'll see that we do have 2 points from our table of values, and sure enough, if we go down 3 and over 4, that slope is in fact the slope between our 2 points. So now what we could do is create more points using the slope. We could go down 3 over 4 again. So this point, which is 5, 6, 7, was it 8, -3, would have to work if I plug those numbers into the equation. And you could actually, I would challenge you to check that on your own. Plug in 8, plug in -3, and it will be a solution. Of course, we could even go this way. We know dropping 3 and going over 4 is the same as going up 3 and to the left 4. And of course, we have the equation, so we know this is not a discrete function. We know this is continuous. We connect the dots. It's really important to do that, so that way if I asked you about the domain and range, you would know it would be all real numbers. And that's basically the equation of the line. Now remember, the power of that slope-intercept is that we wouldn't need that table at all. We already have another point we could have started with, which is 3. Now 3 isn't a pair of numbers, but we don't need a pair of numbers because the number at the end is the y-intercept, and sure enough, that's exactly what we found. 3, which is that point there, is the y-intercept. So typically you solve for y, start at the y-intercept, using slope, rise and run, generate more points, and that's how you can graph. That's the equation of a line. Just so you know, general form, I wanted to mention that because general form is a form that we typically leave a lot of our equations in, and our question is really close to general form. General form is written out as so, but really this is just saying we want all of our terms on one side of the equation, and they have to be integers. Also, a must be positive. So if you go back and look at this original question, if we simply move 12 to the left-hand side by subtracting 12 on both sides, you get 0 on the right-hand side, 3x plus 4y minus 12 on the left, and I just wanted to show you what general form looks like. It's just a way of leaving your final answer that's nice and clean. A is positive, that means the x term is positive. All of the numbers are integers, nice, easy to work with, and it equals 0. This is really a lot more powerful for the next unit, but we introduce it in this unit. Okay, so there's our first example done. Let's go on. Let's take a look now at, instead of giving you the equation, giving you some information, and you have to come up with the equation. In other words, working backwards. I'll just scan down here a little bit. Here's example 2. Start with the first one. Here you're given the slope and the y-intercept. So basically, as soon as you read any time, find the equation of a line, you really want to think about 2 possible equations. The first equation is y equals mx plus b. And I've already talked about that. This is the equation you use when you have the slope and the y-intercept. It has to be the y-intercept. Okay? But we needed a second equation because remember we talked in class, what if you don't have the y-intercept? What if you have the x-intercept? Or what if you have a different point? So that's when you have what's called a point, any point, and the slope. And we have a different formula for that. It's actually the formula for slope rearranged, and it's y minus y1 equals mx minus x1. And remember we talked in class, we said that, well, we know what m is, but why is there a y1 and an x1? And we said that the ones represent the fact that this is referring to an actual pair of numbers, coordinates, that you will need to plug into this equation. Let's give it a try. Let's start with this first example here. You're given a slope of 3/5 and the y-intercept of -2. So what equation do you think you would use over here if you know the y-intercept and the slope? It's the first one. So we're going to write down y equals mx plus b. We're going to substitute in the numbers we know. Notice the y-intercept is negative. I wrote down plus -2, but in most cases we would just write it as -2. What you could do now from here is graph it. The y-intercept is -2. The slope is 3/5, so up 3 over 5. There's my line. You could analyze it. You could find the x-intercept. You could find the domain, range, etc. But I'm going to stop there. I'll do the next example, and I'll show you the next example, another thing you can do. But that's it. There's the equation of your line. The second example, instead of having the slope and a y-intercept, we have the slope, which is -2, and a point. This is not the y-intercept. This is the point 5, 0. And if you think about that for a second, you'll realize that's the x-intercept. But this works for any point. 5 is the x-coordinate. In this case, 0 is the y-coordinate. And what equation are we going to use? Well, what equation would we use for slope and point? Of course, point slope. So let's write out the equation and plug in our numbers. Y subtract the y-coordinate, m, x subtract the x-coordinate. Now in the second example, I'm going to clean this up a little bit, and I could have done that in the first question too. What do I mean by clean it up? Often you're asked to put your final answer in general form. And if you remember, I showed you general form up here. General form is where we have no fractions and it equals to 0. And we're actually pretty close here. 0's gone. I could distribute the -2, giving me -2x plus 10. This, of course, is slope-intercept form. And that would be useful for graphing. So if we wanted to, we could actually graph this line. The y-intercept's 10. So we're going to continue looking at the final answer in general form. Well, we were talking about graphing y-intercept of 10, which I put a point on. If the slope's -2, we know that's -2 over 1. And following down, we end up with, in fact, the same information we had before. Slope -2, and sure enough, it passes through 5, 0. And that is how we find the equation of a line given a point and a slope. Our final example then involves a couple cases here of looking at what happens if you have different information. But really it always comes down to these two formulas. Y equals mx plus b if you know the slope and the y-intercept, and point slope if you have the slope and a point. So if you look at example 3, we're missing something. And of course the first example here is what we're missing is we've got points, the problem there, but points aren't good enough. The equation of a line requires you to have the slope, but of course we did that. We've reviewed the fact that by subtracting the y-coordinates and by subtracting the x-coordinates, you can find the slope. Now, I picked a peculiar one here because we haven't run into a couple special cases, but the steps are all the same for any 2 points. You subtract the y-coordinates and the x-coordinates to get the rise and run. You simplify it. Often we get a fraction. In this particular case, we get a value of 0, which is unique, and our equation is going to look a little different. But again, the steps are all the same. And the steps now involve what formula would we use to find the equation of a line. We have the slope. We have 2 points. We don't have the y-intercept. So yes, we're going to use point slope form. Which point should we substitute in as values for x1 and y1? And I demonstrated this in class that it doesn't matter. Both points are on our line. Both points will give you the same equation because it's the same line. I'm going to use the positive ones, and I'm going to plug them in. Y minus the y coordinate equals the slope, again usually this will be a fraction, times x minus the x coordinate. You can simplify this by, quite extremely, notice we're multiplying by 0. Now again, usually there's a value here that you would distribute, and you would end up with some numbers that we could just now put into either slope-intercept form or general form. But because of this special example I gave you, this side ends up being 0. This actually technically would be called general form because the equation equals 0. If you want it in slope-intercept form, you would solve for y. And remember, in slope-intercept form, it's y equals mx plus b. Why is there no x in this answer? Well, it has to do with that. The slope is 0. So 0x is gone. So 4 is actually the y-intercept. Let's go plot our points and see what this line looks like. Negative 3, 4. 5, 4. We've also got y equals mx plus b. So 4 must be b, the y-intercept. And sure enough, this is the equation of a horizontal line. And I wanted to talk about this because we haven't had many examples of just a horizontal line. Since all horizontal lines have 0 slope, all horizontal lines can be written quite simply as y equals 0x, of course you don't have to write that, plus, and now you just need the y-intercept, 8. This cancels to y equals 8. Now, before I do the last example, think about it. If this is an equation for the horizontal line, what do you think the equation would be for a vertical line? In our last two examples, every y-coordinate was 8. Or every y-coordinate was 4. In other words, the y-coordinate was fixed. Here, the x-coordinate is fixed. X is 7. X is 7. X is 7. So, if this is the equation in general for y horizontal lines, vertical lines are x equals, and then you just need the value x equals 7, the x-coordinate. The reason you can't use slope-intercept form here is because what is the slope of a vertical line? We can't use it because it's undefined. And again, remember when we talked about this is not even a function. So we would not call this a linear function at all because it's not a function. You couldn't come up with data like this if you did an experiment. Okay, our last example then is where we look at tricky questions. Here you're told you've got a point and a perpendicular line. So think about where you've heard that before. We learned that perpendicular lines have slopes that are opposite and reciprocal. So if we could find the slope of this line by solving for y, here we have the slope of -1/2. Now this line is not the line we're looking for. This line, we're told, is perpendicular to ours. It's too bad they didn't say parallel, because we could actually use -1/2. But instead, we're going to find the perpendicular slope by changing this. We're going to flip it and change its sign. So the line we're looking for has a slope of 2. Also remember, we're given the point 3, 5. So what equation would we use if we know the slope in a point? Y minus y1 equals m x minus x1. Let's plug in our numbers. Y minus the y coordinate equals m x minus the x coordinate. Let's now put it in what's called general form. General form means no fractions, no brackets. We need to get it equal to 0, but we'd like our first term, the x term, to be positive, so we're going to move the y value and the 5. We get 0 equals 2x minus y minus 1. And this is our general equation. This is the general form of this last example. Lots of information in this lesson. Go through it carefully if you want. Study, look at the different cases, practice lots. Good luck, everybody, and hopefully this has been helpful.